Good day everyone, we are from SCTK 2711 Thermodynamics and Material Engineering Laboratory, Session 04, Group 3. Our team members are Ayman, Mohammed, me, Jayan, and Singyi. Today we are going to explain about the experiment 3, which is application of first and second law of thermodynamics. The date of the experiment is 14 November 2021. The date of the report submission is 21st November 2021. Our lecturer's name is Dr. Sharil bin Hashim. Thermodynamics can be defined as the science of energy. Energy can be viewed as the ability to cause changes. Thermodynamics can help us in order to predict whether the work can happen or not. The first law of thermodynamics is the conservation of energy principle. It stated that during an interaction, energy can change from one form to another, but the total amount of energy remains constant. That is, energy cannot be created nor be destroyed. The first law of thermodynamics is used as a basis for the calculation of heat transfer. It also used in studying the relationship among the various forms of energy and energy interaction. Besides, it describes some of the fundamental truths of thermodynamics observed in our daily life. For example, when the ball is thrown from the top of the building, it converts potential energy to kinetic energy, and finally, sound and heat energy. The second law of thermodynamics states that when a body interacts with another body at a lower temperature level, energy will flow spontaneously from a higher energy level area to a lower level energy area. Heat can only be transferred from a hotter area to a colder area, but not vice versa. As a result, some of the natural processes are irreversible. Therefore, natural processes that involve energy transfer must have one direction. This law also gives a picture that the entropy of an isolated system always increases with time. The second law of thermodynamics can be expressed by two statements, that is, the Kelvin-Planck statement and the Clausius statement. The Kelvin-Planck statement stated that it is impossible for a device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. The Clausius statement states that it is impossible to construct a device that operates in the cycle and produce no effect other than the transfer of heat from a lower temperature body to a higher temperature body. From both statements, we can conclude that the Clausius statement is more suitable to explain this experiment. This statement states that the energy will be more prone to move from the higher density of energy to the lower density of energy without the need to make any work. The objective of the experiment is to apply first and second law of thermodynamics in various processes. The theory of this experiment is first law of thermodynamics, or also known as law of conservation of energy, stated that energy cannot be created or destroyed but only can change its form from one form to another form. In the first law of thermodynamics stated that the change in internal energy is equal to the net heat transfer to the system minus the net work done by the system. This is the equation, where U out will be internal energy outlet from the system, U in is internal energy input to system, Q is heat rate, W is work done. In this experiment, it requires energy balance equation to calculate the rate heat transfer. So this is the equation that we need to use, where M is mass in kg, Cp is heat capacity, T is temperature.
Hello everyone, my name is Muhammad Salim and I am gonna proceed with methodology. Apparatus. The apparatus used in this experiment are hot plate, two different size of containers, weighing balance, thermometer, and stopwatch. So for the procedure section, firstly, two different size of empty containers were weighed accurately using the weighing balance. Next, a little amount of cold water was filled into the larger container and the mass of cold water used was weighed and recorded. Then a certain amount of tap water was poured into the smaller container and its weight was taken and recorded. The water was then boiled at the range of 80 to 90 Celsius and considered as the hot water in this experiment. After that, the hot water container was placed inside the cold water container as depicted in figure 1. Lastly, the recording of both water temperature for every 1 minute until they reach the same temperature, which is thermal equilibrium, was recorded.
Assalamu alaikum and hello everyone. My name is Ayman and I will carry on with the results of experiment 3. First of all, when we plot the data of temperature versus time of both hot and cold water, we will see that the hot water temperature will decrease with time and the cold one will increase with time in our system, until eventually both the hot water and cold water will reach the same temperature at a time given 18 minutes. And we have the mass of hot water given and the mass of cold water given and the heat capacity of water. And before we apply the change of energy of the system and the energy balance equation on the system, first we calculate the change in temperature for hot and cold water. As we saw on the graph, the T final for both hot and cold water is the same, which is 38.5 Celsius. And the initial temperature for hot and cold water is given. After we calculate the change in temperature, we apply the energy balance equation on the system. First, we put an assumption that the system is insulated, which means there is no energy exchange between the system and the surrounding. So the change in energy of system equal to 0. That means whatever energy comes out from the hot water, it will enter the cold water and there is no exchange with the surrounding. The change in energy of hot water is calculated by the mass of hot water multiplied by the heat capacity of water and the change in temperature of hot water. Same equation applied for cold water. After we add up both change in energies of hot water and cold water, we'll get a change in energy of system, which is negative 4.1 kilojoule. That means the system is not well insulated and there is a slight change with the surrounding.
For our discussion, based on the graph, temperature of hot water dropped rapidly at the beginning of the experiment. The temperature change of hot water is higher than the cold water because the amount of cold water used is larger than the hot water. At the 70 minutes, both water reached the same temperature as thermal equilibrium was achieved. First law of thermodynamics, which states that the energy cannot be created or destroyed, but only can transfer from one form to another, can be used to explain the change of temperature. In this experiment, the heat energy from hot water was transferred to cold water and the surrounding. Results of the experiment corresponded with the second law of thermodynamics. It was proved by the heat transfer from a higher temperature body, which was hot water, to a lower temperature body, which was cold water and surrounding. Based on the calculation, we found that the change in energy for both hot and cold water was negative 4.1 kilojoule, which is not zero as stated in first law of thermodynamics. The negative side illustrated that there was heat loss from the system to the surrounding during the experiment, in which not all the energy from the hot water was transferred to the cold water. It may due to some errors occurs in the experiment. The errors such as parallax error, instrumental error, like we use the low sensitive measuring device, thermometer in contact with the beaker while measuring the temperature. External error due to the air movement and the temperature will also affect the value of experiment. There are some precautions we can do, which is the reading should be taken when the ice is perpendicular with the scale of thermometers. Use a more sensitive electronic balance to measure the weight. Thermometer should not be in contact with the beaker. Carry out experiment in a closed environment. Beaker with hot water should be transferred quickly and carefully into the big container with cold water to avoid the heat loss. And repeat the experiment and get average value. So in conclusion, the first law of thermodynamics that the energy can neither be created nor destroyed, but it can be transformed from one form to another. While the second law of thermodynamics that the heat can be transferred spontaneously only from hot temperature to cold temperature. From the result obtained in the experiment, it can be concluded that the first law and second law of thermodynamics are obeyed. This experiment has been carried out successfully, which some of the heat transfer obtained is up to the surrounding. From this experiment, it is proven that there is no work needed applied during the heat transfer from hot water to cold water process, and the heat is transferred until both had a temperature of equilibrium, which fulfilled the objective of applying the first and second law of thermodynamics. As a result, the temperature of hot water decreased while the cold water increased over time. So these are the references we use in this experiment. First is the thermodynamics and engineering approach. Second is Introduction to Chemical Engineering Thermodynamics. Third is Elementary Principle of Chemical Processes. And fourth is Fundamental of Thermodynamics. So that's all from our video presentation. Thank you for watching.